a few and critical for making predictions on a given input. Signals from these sample-relevant kernels are often more reliable for early detection. Specifically, starting from the final layer, the full connected layer, the kernels that lead extreme predictions such as Cmax and Cmin often has a stronger relevance or mismatching with input. Therefore, we focus on these kernels by tracing back from the extreme prediction in the full connected layer. For example, taking Cmax, the pre-trained full connected weight Fcmax can indicate relevance. By sorting these weights, we can select a top k most relevant convolutional response map channels. But how do we select the kernels in the intermediate layers? Tracing back to the shallow layers, we can identify the sample relevant kernels based on the convolutional response channel selected from the previous layer. Using the weights of these kernels, we calculate the weight for each channel. With these weights, we select the top k channels and continue tracing back. Ultimately, leveraging response from the sample-relevant kernels, we establish a revised OD score for the pertinent layer. Let's look at an overview of our CORES framework. Our approach consists of two key steps. First, backward retracing from extreme prediction to identify sample-relevant kernels. Second, the OD score is derived from the response magnitude and frequency from these kernels, highlighting the differences between ID and OD characteristics. In the experimental section, we test the effectiveness of CORES across various models and datasets, achieving optimal results in most of cases. Our framework excels not only in standard early detection, but also in near early detection. This is particularly important for situations where the direction between ID and OD samples is subtle and more challenging to discern. We also conduct an ablation study on the 4 CORES matrix, which reveals that each metric is essential to CORES performance. Furthermore, we evaluate the influence of kernel selection on OD detection efficacy. By analyzing the CORES OD score distributions, as the figure shows, applying kernel selection within CORES significantly diminishes the overlap between ID and OD score distributions, leading to a notable decrease in FPR. To illustrate the efficacy of the 4 CORES matrix, we present a visualization of RM, RF across ID and OD images. As depicted in figure, ID images consistently show higher values for RM and RF compared to OD images, confirming that the CORES matrix proficiently differentiates between ID and OD samples. Thank you all for your attention. I hope this video provides valuable insights in our work on CORES convolutional response-based score for out-of-distribution detection. For more detailed information, please refer to our paper.